Our first session is the Apache Druid Vision and Roadmap. Our speaker is Gian Merlino. He is the co-founder and CTO of Imply and the PMC and main committer for the Apache Druid project. Previously, Gian has led a data ingestion team at MetaMarkets and held senior engineering positions at Yahoo. He holds a BS in computer science from Caltech. He's also a very awesome human, and I don't just say that because he's my boss. So without further ado, here is Merlino, the head of the Druids.
Hey everybody, can y'all hear me?
Yes.
Good. All right, that's one is enough. I hope you guys are all having fun. I was really hoping to be seeing everybody in person today, but unfortunately, life comes at you really fast, and we didn't get to do that, and we might not get to do that for a while. So, you know, at least we're doing something virtually, and that's fun. I wanted to do a little talk today about called taking the temperature of our data. That's about a little idea about how different kinds of data sets have different temperatures and how we think about that. And while talking about that, I'll also talk about the Druid and where it is and where it's going and some roadmap stuff and how it ties into this data temperature idea. So without further ado, let's see. Without further ado, let's go to the next slide. Okay, so first off, who am I? I'm Gian Merlino. Everything Rachel said is true, except for one thing. There's no main committer. We're all equal committers, so but everything else is true. I'm a committer and PMC chair at Apache Druid. I'm a co-founder at Imply, and we are hiring for Druid stuff. If you want to do Druid stuff and get paid for it, come on down. One thing I want to talk about is the real Druid Summit. So this is a virtual Druid Summit or an imaginary Druid Summit, if you will. It is still cool. It's a little bit scoped down. There's going to be a handful of talks in one day. The real one is going to be a 3-day thing. It was supposed to be this week. It'll be in November now, hopefully, assuming we can get this whole situation in the world in control by then. With talks from a ton of people, Netflix, Twitter, NTT, so on and so forth. Training on the first day, talks on day 2 and 3 in beautiful San Francisco at the Marriott, which I am sure will be happy to have business at that point. Check out druidsummit.org. And so when I was planning this talk, I was putting together my outline for the slides. And my outline started with slide number 1, plug Druid Summit. Slide number 2, some kind of joke about coronavirus. So this is the best I come up with. The industry is here to help. That's good to know. It's in these tough times. It's for those of us in non-essential roles outside the medical profession and outside the grocery stock shelving profession. It's hard. It's easy to feel like we can't help and that there's nothing we can do to, help the world get back on track. But we can. We can put up dashboards, and in fact, so many of us have. Many vendors did this. We even did one. There's an implied pivot in the top right. It's definitely unnecessary to have 50 of these out there, but yet there are. And I just like to think that everybody's trying to do what little they can to help with the coronavirus situation. So, take what you will. But anyway, we're here to talk about Druid. So I wanted to talk a little bit about where Druid is right now and Druid in the wild. These are some, I went scouring the internet for people that wrote recently about what they're using Druid for and see what people are up to in the Druid world these days. There's a few recent posts here from Netflix, Mopub, which is a Twitter company, and Airbnb, all doing really cool stuff with Druid. And there's a lot of commonalities in what they're doing. They're all doing stuff at scale. Druid's kind of known for performance at scale. I think that a lot of the talks you're going to hear from today, and a lot of you, if you're using Druid, are people that are interested in those kinds of things. So some of the numbers pulled out of these posts, 100+ billion rows per day, trillions of rows in retention, over a year of retention, hundreds of servers per cluster, query latency of sub-seconds, just a few seconds, even given those stats, and a mix of streaming and batch ingestion. So I guess this is to say that when you're talking about performance at scale, Druid's the real deal. But performance at scale for what? What are people using Druid for? Well, people are using Druid for real-time workflows. They're using Druid for a lot of stuff, but this is, I would say, one of the most common things to use Druid for. And what real-time workflows are a marriage of exploration and monitoring. And I'll talk a little bit more about what I mean by that, but in future slides. But I want to just intro it by saying exploration is you are interacting with data, you are trying to figure things out, you are trying to diagnose issues, you're trying to troubleshoot, you're trying to find root causes. It's an iterative process where you make a query, get a response, based on that response, make another query. And it's typically done through a user interface, through a graphical user interface, because exploration is a rapid iterative process and no one has time to type out long SQL queries when trying to do a data exploration. So you want to do it through a UI. And then monitoring is looking into the current status of some system. Monitoring involves functionality like alerts. It involves functionality like being able to see what's happening in real time. And they go together because you can use monitoring to identify issues and then exploration to really dig into them and troubleshoot them. And then these exploration and monitoring pieces together form the real-time workflows that are so popular with Druid-powered applications. So this is an application that we made at Imply called Imply Pivot. It's an app that's, if you look at it, it looks like a little bit of a cross between BI apps like Tableau and monitoring apps and slice and dice apps like Kibana and Grafana. And that's not an accident. It's meant to be kind of have a feel of real-time slice and dice, real-time dimensional analysis, real-time aggregations and measures and that kind of stuff. So it's meant to let you fly through your data. That's why I like to use videos to show the purpose of it, because the whole point of it is the user experience and the interactive exploratory user experience. We built this to run on Druid because we wanted to build what we felt was the canonical hot application for dealing with real-time data. So when it comes to the Druid roadmap, a lot of the roadmap for Druid is, well, one thing I like to say is there actually is no single roadmap for Druid because the roadmap for Druid is driven by a community. And people can bring their own things to the roadmap. So when I talk about a roadmap in this sense, this is really the roadmap for the things that I'm involved in, for the things that Imply, the company that I work for, is involved in. A lot of this is about investing in real-time experience. So investing in real-time experience means a couple of things. Number one is performance, and number two is ease of use and reliability. These are the two pillars, I think, of having really good real-time experience. Performance obviously is number one. That's the key to having real-time experience. And some of the stuff we're doing there, roadmap-wise, in the very next release, Druid 0.18, which is actually likely to be out within a few days, is query laning, which is a really cool feature that allows you to think of it as a carpool lane and a regular lane on the highway. So high priority queries can go through the carpool lane and low priority queries can go on the regular lanes. And so high priority queries always get the ability to flow through the system, even if low priority queries get stuck up on each other. So the ability to have intelligent resource management, and that's coming in the very next release. Then beyond that, in later releases, a fully vectorized query engine, which we're expecting to speed up queries by substantial multiples. On the ease of use and reliability fronts, indexer process is a big thing. Those of you that use Druid know there's a ingestion has this thing called a middle manager where every task has its own JVM. We're sort of simplifying that, reducing the number of JVMs involved in deployment. Robust native batch ingestion, the next point. So making it so Druid can ingest from cloud data stores like S3 and stuff like HDFS whatever data you have, whatever format you have, whether it's giant files or tons of small files, really robustly. And then third thing, partition-aware background compaction. So you can go through your data in the background and optimize it for the best performance possible. So these are all things that we're working on that are about investing in that core real-time experience in Druid. Now getting onto the temperature thing, the whole point of this talk is let's think about data as having temperatures. So everything we've been talking about up until now is this real-time data, which is this core use case for Druid, and does drive a large chunk of the roadmap. And you can think of this as hot data in terms of temperature. So on the left, I have this picture of hot Cheetos and Takis and some other hot stuff. And what defines hot data is the queries need to be fast. So the queries need to be sub-second to just a few seconds. You need to operate on fresh data. It's going to be a high concurrency system because you imagine those videos that I had a few slides earlier. Even one user can drive a substantial amount of load, and you're going to have a lot of users on the system. And it's also going to have highly interactive workloads. So having a lot of users, interactive workloads means high concurrency. So this combination of needing fast queries, fresh data, high concurrency, interactive workloads is what hot data is all about. That stands in contrast to cold data. You know, the whole point of thinking about a temperature scale is we have hot and we have cold. So cold data on the picture there is we have this warehouse of government cheese, and this is your data warehouse. Your data warehouse is where you put your cold data. So in your cold data store, slow queries are okay. You prefer them to be fast, but you know it's fine if they take a while. Less fresh data is okay. So you don't need to have data that is up to the second. It's okay if it's a few hours old or even a day old. You're generally going to have low concurrency for this cold data. So you know it's going to be driven by a relatively smaller team of analysts. It's not going to be used by everybody in your company. It's going to mostly be used for reporting and for planning. So not highly interactive workloads, but workloads where most of the queries are reporting queries or planning queries that are sort of figured out ahead of time. So that's hot and cold, the two ends of the spectrum. But what about warm? Warm is, do we have warm data? We actually do. I think that there is a lot of warm data, and warm data is pretty interesting. So for warm data, we have this nice warm loaf of bread straight out of the oven. Everybody's baking bread these days. So that's what we have here. 5 to 30 second query. You don't need queries to be sub-second. Of course, you'd always like it if they were, but it's not really necessary for warm data. But you do need them to be fast enough. And what fast enough means in this case is they can't be a minute, 2 minutes, 5 minutes. They need to be fast enough that when someone issues a query, they're not going to be tempted to get up and go get a coffee or switch to another browser tab and start reading the news. You know, they can actually, it takes a little while, but they can keep paying attention. So 5 to 30 seconds. Less fresh data is okay, still here. So we're not looking at real-time up to the minute data. We are okay having data that's a few hours old or a day old. But we do have high concurrency. So unlike cold data, we are going to have a lot of people trying to do stuff here. And it's going to be somewhat interactive. So that's what's driving the need to have these somewhat faster, warmer query times. We want to do somewhat interactive work. It's not purely reporting. It may not be as you know, aggressively interactive as those pivot videos, but it's not going to be just pulling reports. So this is, I think actually a lot of data sets fall in this category. These are data sets that you do want people to be using throughout your organization for decision making, but you don't have a necessarily strong need to make them available in real time and make them available as a hot data set. So, but that begs the question, what's the point of this? What's the point of a warm data set? Why not just go all the way and make it hot? Well, there's two reasons. One reason is cost. So, you know, a system that is achieving 5 to 30 second queries on 10 terabytes of data, and a system that's achieving sub-second queries on 10 terabytes of data, you know, apples to apples, the sub-second query system is going to be a lot more expensive. So for cost reasons, if you don't need queries to be that fast, if you're not doing very highly interactive workloads, you might be tempted to scale back the system and make it warm instead of hot. Another reason that warm instead of hot is useful is ease of data migration. So if you think about the way the data is stored in hot systems like Druid, in a hot system, your data probably came from a stream, or it probably came from a denormalized data file. You probably did a lot of data prep on the data before getting it in to make sure it's in the right format to really optimize your queries. You probably designed your schema based on the application you're going to be using it for. That gets you that performance, but there's a bit of overhead in terms of data modeling and getting data into it. What's nice with the warm system is, or what's nice with a warm system that relaxes the query speed requirements. We don't need sub-second, a few seconds, 5 to 30 seconds is fine. With those requirements, we don't actually need to do a lot of that stuff. We can ingest data in the same basic structure it would be in a data warehouse. So using a star schema or a snowflake schema like a data warehouse would. And that makes it easier to migrate data because you don't have to change the way you think about it and the way you model it. So those are two reasons, cost and ease of data migration, why it does make sense to have 3 categories of data, not just 2. So let's think about the warm user experiences. And now that we think this warm data set makes sense, what kind of user experience are we trying to power? It's still exploratory, but it's less interactive. So on that hot data set, you imagine someone, if queries are sub-second, it's going to be a very interactive experience where someone clicks, they immediately get a response, click again, immediately get a response. Really useful for digging into very complex data. That's very highly dimensional and people need to look at from a lot of different angles. That stuff, you really need to be hot. These warm experiences where there might not be as many angles to look at the data, maybe there's only a few ways to look at it. And so if the queries are longer, it's fine. So it's somewhat less interactive. And not much monitoring for this warm data. So you're not going to be doing much in the way of alerting. You're not going to be doing much in the way of real-time monitoring or taking real-time actions based on data because it's probably going to be a few hours or day old. And for these user experiences, for this kind of user experience, the classic BI apps actually work pretty well, like Tableau and Looker and that kind of thing. They don't really work well for hot use cases. That is why we built Pivot at Imply, but I think they do work well for these warm user experiences. So what that means, that brings us back to the roadmap for Druid. How that affects how we think about the Druid roadmap is we actually want Druid to, we want to invest in this real-time hot use cases. That's what these first and second bars of our roadmap are all about. But then there's this third bar of the roadmap that's about expanding into these warm use cases. Because it actually does make sense to think about, let's say you want to be able to, let's say you want to relax your query speed requirements and lower your cost, you shouldn't have to switch to a different system. Or let's say you want to relax your query speed requirements and use that flexibility to just load data from your classic data warehouse in the same schema it was in your data warehouse and have it still work in Druid. So that's what warm capabilities are all about. And the bar we need to power that is query capabilities. Because to be able to do a star or a snowflake schema, you need to support joins. To be able to do a lot of the use cases that you would have done with the classic data warehouse and BI stack, and even to run a BI application like Tableau on top of Druid, you need to support joins, you need to support subqueries in SQL, you need to support windowed aggregations. And so these are all things that are on our roadmap in order to add capabilities to support these use cases and support running BI applications directly on top of Druid for warm use cases. So that's stuff like SQL joins and subquery support. That's actually coming in the very next release, 018, which again is due out in a few days. And then joins v2 coming in the future, adding support for outer joins, right joins, and wider dimension tables. The first versions can support skinny dimension tables, basically the classic lookups that are in Druid if you're familiar with those. And then also coming in the future, windowed aggregations in a future release. So these 3 pillars of the roadmap that we think about it for Druid give us the ability to put a lot of our effort into doubling down on being the best that we can for real-time hot use cases, but also being able to support warm ones and being able to seamlessly transition between hot and warm within the same system. And also being able to transition your cold data into warm by loading it from a data warehouse or from S3 or HDFS into Druid using the same schema you're familiar with. If you want to make it hot, then you'll probably still need to do some of the things that you want to do for hot data today, such as denormalize it, potentially go to streaming, and all that kind of stuff. But you can get some of the benefits by going from cold to warm.
Hey, Gian, just let you know you've got
yes.
you've got about 10 minutes at this point.
Perfect, because I think I have a couple more slides left. So that's how we think about the roadmap for Druid. At least that's how I think about it. And part of this is thinking about the roadmap for Druid is thinking about towards Druid 1.0. Those of you eagle-eyed folks in the Druid community have noticed that Druid is 0.17 now, and 0.18 is coming out soon. Maybe at this point, I think it's a little bit. I think it's a little bit. It's funny to me, or it's fun to me that we have a system that's in production at these massive sites at places like Twitter and Netflix and Airbnb and so many others, and everyone you're going to hear from today, using it for really critical workloads that isn't 1.0 yet. So it's about time that we call it 1.0. I think that it's really almost a formality, but it gives us the opportunity to think about bridging this gap and making this transition. So we want to use it we want to think about it in that way. So we want to think about these efforts coming together as part of Druid 1.0. So we want to think about the coming together of this native batch ingestion work, this new and improved higher performance query engines, and improved SQL support to support these warm use cases. And we want to think about these things all coming together into a Druid 1.0 package later this year. So stay tuned for that. And stay in touch. I think this is my last slide. You can follow us on Twitter at Druid.io. You can join the community. We have mailing lists, we have Slack, we do meetups. The meetups are all online now, but one day we will start doing them in person again. There's a lot of other ways to get involved on the website at druid.apache.org/community. Thank you. I think 6 minutes for questions.
Yeah, we got a load of them actually. So let's start with cost-wise, considering hot, warm, cold examples. Is the cost proportional to the temperature? Is a data set that is old a few months but still needs to be served under a second with near real-time latency considered hot?
Yeah, I would say so. I would say that well, I'm not, was that two questions? I only heard the last one. So it was two questions. You might need to repeat the first one, but the last one was about if it's a lot of retention, but you still need subsequent queries, I consider it hot. Yes. To me, what defines the hot temperatureness of a data source is how fast the queries need to be and how fresh it needs to be. So if you need to have sub-second queries, I would say it's definitely hot. If you need to have real-time data, it's hot. The fact that you have a lot of retention is fine. There's plenty of people using Druid for situations where they need sub-second latency and lots of retention, and it works fine.
Awesome. And we've got lots of questions about joins, not surprising.
Sure, pick your favorite.
Can you talk a bit about how join version 2 will expand the capability beyond lookups? Is this still only dimensions or metrics too?
Good question. Well, I don't know the details because we still are sorting that out, and that's a good incentive to sign up to follow us on GitHub and join the mailing list and all that, because that's where we sort out these ideas. But I would say the goal of the next stage, with regard to what you're asking, which is supporting more tables, is to support tables that are wider than lookups. So lookups are just a one key and one value. So wider than lookups and can have multiple types. Lookups are all strings. So, imagine a table with n columns and both string and numeric types.
So I think that answers the second question too, which is join supported on any column or just times? So it sounds like it's going to be supported on any column. Yeah,
it's going to be hard to actually use that support in this first release because you'll be mostly joining against lookups and subqueries. But the framework is there, and it is available for lookups and subqueries in this upcoming release, and we'll be expanding it aggressively in future releases.
Awesome. In the case of warm data in future versions, is data going to be served from SSD or load from deep storage at query time? And how is the cost reduction going to be achieved?
That is an excellent question. So I think both are options. I think serve from SSD is definitely an option. There has been talk in the community about building functionality to query directly from deep storage, so that could be a part of it. When I was talking about reducing costs for warm data, I was mostly thinking about compute cost, because for hot data, what I've seen is that people tend to be driven by they tend to be driven by CPU rather than by memory when scaling their clusters. So they tend to actually be CPU bound. And when you relax those query speed requirements, you can really cut back on the number of CPUs you have, and then you might become storage bound or memory bound, but you'll have less hardware.
Fantastic. Will we still be getting sub-second performance on join queries?
Well, I guess it depends on how big your tables are. I think of it less as, are you going to get sub-second, and more as like, what's the ratio in speed between a query that's on a star schema and a query that's on a flat table. You know, a query on a star schema will never be as fast as a query on a flat table. You know, if the query on the flat table is 200 milliseconds, then the query on the star schema might still be sub-second. But if the query on the flat table is barely sub-second, then the query on the star schema will probably not be sub-second, is how I would think about it.
So is there anybody else who has a question for Gian? We've got about 2 more minutes left of the session. You're welcome to ask questions in the G&A panel, Q&A panel down at the bottom. Okay. Is a Kubernetes operator under development? Community right now doesn't have a proper operator.
Well, at Imply, we have a proprietary product that is a Imply manager for Druid on Kubernetes. And so we've built that, and you're free to check it out. So because of that, we are not likely to be ourselves driving a community version of that.
And last question, do you think the JSON query API will eventually be deprecated?
That's a good question. Maybe. I think that it will become less and less prominent in the documentation over time, for sure. I'm not sure if it will ever be deprecated, but it may become more of a advanced power user feature that most people don't use. We're definitely moving towards SQL as the standard.
Okay, I think we probably have a few more. People are all just piling in right now. And the questions that we don't get, Gian doesn't get to, we will answer in a blog post, follow-up blog post. So, you know, keep them coming. Is there any plans to include visualization capabilities in the community console?
Ooh, that is a very interesting question. And all I'm going to say to that is keep your eyes open.
Fantastic. Well, it is the, like, what is it, the bottom of the hour, I guess? That is all the time we have for it. Thank you so much today for your time, Gian.
Yeah, definitely. This is super fun. I wish that we could have all been hanging out in person and, you know, chatting with each other afterwards, but we'll have a chance to do that later in the year.
Yeah, we continue to host virtual AMAs through the Meetup group. So if this was something that you're interested in asking more questions of Gian, one, be sure to check out our fireside chat later on today, but then also our virtual meetups that we're going to be hosting, you know, throughout the next few months.